AWS gives you many ways to connect things: Internet Gateway, NAT Gateway, VPC Endpoints, PrivateLink, VPC Peering, Transit Gateway, VPN, Direct Connect, Cloud WAN, and several edge entry patterns. The mistake many teams make is treating them like interchangeable wires. They are not. Some are for users reaching applications. Some are for private workloads reaching out. Some connect a workload to one specific service. Some connect whole networks together. Choose the wrong one and the design gets expensive, insecure, or hard to scale. In this video, I will show you how to choose the right connection pattern. Here is the framework. Ask 4 questions. First, what is connecting? A user, a subnet, a workload, a VPC, an AWS service, or an on-premises network? Second, who starts the traffic? Is it inbound from users, outbound from a private workload, or bidirectional between trusted networks? Third, does the path need to stay private? That question alone can eliminate the wrong services quickly. And fourth, how big is the network shape? One thing to one thing, a few VPCs, many accounts, or a global environment? Once those answers are clear, the AWS networking choice becomes much easier. Before comparing product names, group the problem into connection categories. The first category is user to application traffic. That is where CloudFront, ALB, NLB, and Global Accelerator usually enter the conversation. The second category is subnet internet access. That is where Internet Gateway and NAT Gateway matter, and they solve 2 very different problems. The third category is private service access. That is when a workload needs S3, DynamoDB, an internal API, or a shared service, but should not use the public internet path. The fourth category is network-to-network routing. That is where VPC Peering and Transit Gateway belong. And the fifth category is hybrid or global networking. That is where VPN, Direct Connect, and Cloud WAN make more sense. If you classify the traffic pattern first, you stop guessing and start designing. If public users need to reach your application, think at the edge first. CloudFront helps with global delivery, caching, and better user proximity. ALB is strong for HTTP and HTTPS applications that need smarter application layer routing. NLB is better when the traffic is TCP or UDP, and you care about high-performance transport behavior. Global Accelerator helps when you want global entry points and more consistent user paths into AWS. If a subnet itself needs direct internet reachability, that is the Internet Gateway use case. Public subnets are public because their route table sends traffic toward an Internet Gateway, and the workloads are intentionally exposed through that path. If a private subnet needs outbound internet for updates, package downloads, or external APIs, that is the NAT Gateway use case. NAT is for private workloads going out. It is not how you publish inbound internet traffic to an application. Now let us move to private access patterns. If private workloads only need AWS services like S3 or DynamoDB, check VPC endpoints first. That keeps the path private and can reduce unnecessary public internet exposure. Many teams send too much traffic through NAT when the workload did not need the public internet at all. If the problem is one VPC or one account consuming a specific service from another VPC, PrivateLink is often the better fit. The key idea is that PrivateLink exposes a service, not your whole network. If 2 VPCs need a simple private connection, VPC peering works well. But peering becomes harder to manage when the environment grows, because you start building a mesh of one-to-one connections. Transit Gateway is the better fit when Many VPCs, many accounts, shared services, VPNs, or direct connect attachments need central routing. Choose the smallest connection scope that solves the problem cleanly. Endpoint, PrivateLink, Peering, or Transit Gateway. When on-premises needs to reach AWS, the first question is usually speed of setup versus network quality. Site-to-site VPN is often the quick starting point. It is encrypted, internet-based, and useful when you need hybrid connectivity quickly. That makes VPN practical for early hybrid designs, lab environments, disaster recovery paths, or an initial bridge while the long-term architecture is still being built. Direct Connect is the enterprise option when the business needs dedicated private connectivity, more predictable bandwidth, lower latency characteristics, or larger steady data transfer. But Direct Connect is not just a better VPN. It usually comes with more planning, provider coordination, and resilience design expectations. If the problem grows into a centrally managed global network across many regions, many accounts, many VPCs, and branch locations, Cloud WAN becomes the conversation. In larger environments, these services often work together. Transit Gateway for routing, Direct Connect for the dedicated path, VPN for backup, and Cloud WAN for global policy. Here is the production lesson people often miss. A route existing does not mean traffic is allowed. Routing decides where traffic can try to go. Security groups, NACLs, firewalls, inspection layers, and policy controls still decide whether one workload can actually reach another workload on a specific port. That means you should never look at a route table and assume the architecture is complete. NAT gateways can become expensive if every private workload, every download, and every service call is forced through them by default. VPC endpoints and cleaner private access paths can reduce unnecessary internet egress in those cases. VPC peering stays simple only while the network stays small. Transit Gateway simplifies topology, but only if route tables, segmentation, and inspection paths are designed deliberately. VPN is encrypted, but internet path performance can vary. Direct Connect is more stable, but it still needs resilience design, failover thinking, and security controls around it. So the mature design question is not just, can these things connect? It is whether they can connect privately, securely, cost-effectively, and in a way you can still operate later. So when two things need to talk in AWS, start with the connection pattern, not the product name. Ask whether the problem is user-to-app, public subnet internet access, private outbound internet, private service access, VPC to VPC routing, hybrid connectivity, or global network management. Then ask who starts the traffic, whether the path must stay private, and how much scale the architecture really needs. If you do that, the AWS service choice becomes much easier, and you avoid the common mistake of solving a small problem with a large connection or a large problem with a connection that will not scale. If this was useful, follow Trustscrin for more practical cloud architecture, Terraform, Kubernetes, and AI engineering videos.